Well, let's take a look at these two examples. We want to add these two fractions with like denominators. Okay, Kirk, can you tell me how did you start this one and what did you do?
I added the top numbers, 4x plus 12, and added the bottom numbers and got x plus 3, and then I simplified to 4x plus 4 over x plus 1.
Very good. So you simply added what we have at the top of the fraction, x plus 10 plus 3x plus 2, and then you kept x plus 3 here because it's the same. So, and then you looked at the top and you noticed that here we have 4 in common, so we factored the 4 out. So here we get x plus 3, and then we can reduce this now. So x plus 3 and x plus 3 turns to 1. So the whole thing would be equal to 4 over 1, or just simply 4. Very good. Let's see, Patricia, what did you do? How did you do the second one?
I'm not sure if I got it right, but I basically subtracted x to the second from 2x to the second, which gave me 2, I think, and then negative 3 minus 22, which I got negative 25. So that would be negative 23 over x minus 5, I think.
So you're right, at the top of the fraction we just write it as you're subtracting this, but don't forget that leave this parentheses here. So because this minus here belongs to both of this, we need to distribute this now. We need to distribute this minus or minus 1 here. So when we do that, we get here minus x to the power of 2 minus 22. And if you look at the bottom of the fraction is the same, so we keep it as x minus 5 here. So now we need to combine like terms. The top of the fraction, now we have 2, this is 2x to the power of 2, which is right here, minus 1x to the power of 2, so it would be a total of 1x to the power of 2, just x to the power of 2. And then when we combine like terms here, we have minus 3 and minus 22. Let me go back to Patricia. Patricia, what did you get for the constant? Did you distribute this minus correctly? There's a little delay with your voice, so you have to click on the microphone and talk after that, and keep it on for a while. So tell me if you did this correctly, and if you didn't, what did you do wrong?
Yeah, I did it mostly correctly. I think I just subtracted the x to the second wrong.
So what did you get? I'm curious. What did you do wrong? What did you get for x to the power of 2?
I had just got 2. I thought that the x to the second canceled each other out, but now I see it's 1x to the second minus 25 over x minus 5.
I see. So if you have 2x to the power of 2 minus 1x to the power of 2, this is just like you say I have 1 one apple here. X to the power of 2 is like an item. A minus, and then here I can write this as 1 apple. That's what it is. So if I ask you if you have 2 apple minus 1 apple, you certainly can give me the correct answer. Then you say 2 minus 1 would be equal to 1, and the items doesn't change. The item stays the same here. In this case, being apple. Whereas here, instead of apple, here we have x to the power of 2. So if you have 2x to the power of 2 minus 1x to the power of 2, that'll give you 1x to the power of 2, of course. Okay, now let me go back to Kirk. Kirk, can I simplify this? What do you think?
Yeah. Would it be
Okay, your microphone is not that great today, but you said yes, you can factor, and then can you go and tell me how do you factor it then? How do you factor x squared minus 25, if you know? Is this factorable? If it is, how do you factor it?
You factor out x times 5 from the top, so you get 5x times x minus 5.
Well, we don't have anything in common between these two. We don't have the 5x common between these two, so we cannot factor a 5x between these two. But these both are difference of square. See if you remember the formula. Anybody remember the formula for difference of square? If I have a squared minus b squared, anybody know how to factor this? Okay, those of you who have don't have a microphone, you can type your answer. But let me go back to Patricia. Patricia, do you know how to factor this?
No, I don't think so.
Okay, Kirk, how about you?
Is it a minus b in the first parentheses, and in the second parentheses, a plus b?
Very good, exactly. That's exactly how you factor it. And I see students without the microphone responded the same way. So you need to know how to factor difference of square. In this case, if you have a squared minus b squared, would be a minus b times a plus b, obviously. So if I have x squared minus 25, we do have a difference of square here. So this is x, your first term is x, your second term is 5, because 5 squared is 25. So let me go back and ask Patricia. Patricia, can you tell me if you substitute for each a and b, x and 5, how do you factor this now? Can you tell me? Okay, let me give you a microphone back. Sorry about that. Go ahead. Then I give you a microphone. Tell me when you substitute here, what do we get?
Would it be x minus 5, x plus 5?
Exactly. Your first term, your a is x, so that's where the x goes. And your second term, b, is 5. That's your b. So that's where the b goes, right there. So your b is 5. So it would be x minus 5, x plus 5, absolutely. So in this case, if I factor this, you see I can reduce this. I can reduce this to x minus 5 times, factor to x minus 5 times x plus 5, and then reduce x minus 5 like this. And then I would get, the whole thing would be equal to x plus 5 over 1, or just simply x plus 5.